Hi everybody, good afternoon. We're going to talk about biomolecules again. This is our second video and today we focus on carbohydrates. So carbohydrates function is to have short-term energy storage. So if you have a little ice cream, that means you are going to get quite some energy for later, okay? But that's why you feel so excited when you have some ice cream, okay? Because you have just consumed lots of energy, lots of carbohydrates. So we're going to have three different classifications. First, according to functional group and number of carbons. Second, number of units. And third, type of bond. So functional group, okay? So for this functional group, we're going to focus, okay, on what do we have present. So for carbohydrates, you will notice that you have carbons and hydroxy groups, okay? And each of them can have either an aldehyde, okay, or a ketone. So hydroxy groups are a quality that is among both these two, okay? What can change is that if you have an aldehyde, it's going to be an aldose. If you have a ketone, it's going to be a ketose. And then it would be also classified as D or L. D, if you have the penultimate hydroxy to the right, and L, if you have it to the left. So D and L, okay? So the final step in here is to be able to write down their names so that you can communicate accurately, okay? So they don't really follow UPAC nomenclature. So the way to write the name is the following. So for number one, okay, we have D, because we're going to specify which kind we have. The penultimate is on the right, so it's a D. And then aldo, because you have an aldehyde here, okay? And then hex, because you have 1, 2, 3, 4, 5, 6 carbons. And O's, because it's a sugar, okay? Number two, this would be the second example. We have L, because this is an L carbohydrate. Keto, because we have a ketone. Hex, it's hex again. 3, 4, 5, 6 carbons. Okay, and finally O's, because we're talking about the sugars. Okay, so I'm gonna leave this here for you to check out. So, alrighty, so then we have number of units. So what is that classification about? So if you have one unit refers to one of these, okay, but in the closed structure. So when these are closed, they would look something like this, hexagons or pentagons. So one structure, one unit, okay, one of these by themselves, it's a monosaccharide. If you see two of them joining hands, kind of, okay, hand in hand, then that's a disaccharide. If you see 3 to 10, so for example, okay, we have this already. That would be an oligosaccharide, right? And then we have, if you have more than 10, it's a polysaccharide. So monosaccharide, the most important is glucose because we have it present everywhere. Okay, so glucose is the monomer, or a monosaccharide is the monomer of carbohydrates. Okay, disaccharide, okay, we have a few important disaccharides. We have, for example, lactose that you consume every day if you like milk. Okay, you have sucrose, that if you like soda, regular soda, well, that's your fort. And finally, we have maltose, okay, which is what beer is made of. Okay, then we have some of the most important polysaccharides, which are starch, like potatoes, that's where plants store their energy, glycogen, where animals store their energy, and then cellulose, okay, which is for structure, okay, stability of the plants, stems and leaves and stuff, okay. Finally, all right, we have according to the type of bond, okay, or the monosaccharide itself. So for this, let's draw one monosaccharide. Okay, it's your hexagon. Okay, all monosaccharides are always numbered like this. You notice this oxygen? Well, we're gonna have, this will be carbon 1, this is 2, this is 3, 4, and 5. Okay, like in the clock. All right, so we're going to focus on carbon number 1. Okay, and in that carbon, you will have a hydroxy group. You will see if your hydroxy group is going upwards, it's going to be beta, okay, a beta monosaccharide. Okay, if on the other hand, okay, that hydroxy group is going downwards, OH, the other one being a hydrogen, okay? If it's going downwards, then it's going to be alpha, okay? The same is going to happen if you have a bond. So let's say you have one like this, okay? All right. It's said to be a 1, 2, 1, 2, 3, 4, 1 to 4 bond, okay, because this is the order of your carbons. It's from carbon 1 to carbon 4, and it's going upwards, so this would be a beta glycosidic bond, okay. And then if you notice, we can have the other version as well, okay. If you have, for example, okay, that bond going downwards, it would be an example of an alpha glycosidic bond. All right. Very good. Now time to categorize a few of them. Okay, so for example, this kind of glucose, what do we have? Okay, we're going to see that you have carbon number 1, which is this one. You'll see here, and you have your hydroxy group going downwards, so it's going to be alpha. Okay. If you notice on this other example, we have a disaccharide and it's going upward. So it's going to be, it's going up in the up direction. It's going to be beta. Okay. And finally, for example, we're going to have, okay, this, alrighty, which is, okay, one of our very important ones, disaccharides, which is lactose, like a lactose unit with a glucose unit. We're going to have that it's going upward, so it's a beta one, okay? Finally, you have different conformations. You can show these carbohydrates also in a chair conformation, okay? But it's also hydroxys on each carbon and a bond, and it's going downwards, so it's an alpha, and this is an example of maltose, a glucose and a glucose, okay? And finally, just to see the last one, we have a glucose and a fructose, and they are going downwards. This is an alpha bond because it goes down. Okay, here it goes down. Okay, so it's alpha, and this is an example of sucrose, for example, glucose and fructose. Okay, well, thank you very much. Hope you enjoyed it. All right, so functional groups, number of functional groups, number of units, and finally the type of bond present.